Okay, let me explain a bit more. You will see that we are going to sample beta and sigma square 11,000 times. Okay, then the first 10,000 is called burn-in or burn-in size. The following the 10,000 is called simulation size beyond the burn-in. Okay, the burn-in simulation is not going to be used for computing posterior mean and variance. The samples from the iterations after the burn-in will be used to inference the posterior. Okay, here again the n0 is the burn-in and n1 is the simulation size after the burn-in. So this is sample of beta from n0 plus 1th iteration, and sigma square n0 plus 1 is the sigma square sample from the n0 plus 1th iteration, and so forth, like this. Okay, so then we have what? We have n1. We have n1 samples for beta and sigma square. Then the first column is posterior samples for beta 1. The second column is posterior samples for beta 2. The third one is samples for beta 3. The last column, okay, here. Okay, so the last column is posterior sample for sigma square. Okay, so then this matrix defines the posterior distribution of, or I would say joint posterior distribution of beta and sigma squares. So these are samples from the joint posterior distribution of beta and sigma square given y, right? Okay, so then the first line is what? The first line is marginal distribution of beta 1. The second column, so the second column is marginal posterior distribution of beta 2. The third column is what? Marginal posterior distribution of beta 3. Okay, and then what we want to know is the mean and variance of the coefficient. For example, for beta 2, the posterior mean of beta 2 is just mean of the second column. The variance of beta 2 is simply the variance of this second column, right? Then that's it, right? And also we can compute the 90% or 95% credibility interval. So in the frequentist approach or the econometrics one, it was called confidence band. But in this Bayesian approach, we called credibility interval. Okay, so to compute 90% credibility interval, what do we have to do? We can sort the samples. We can sort these 10,000 samples. Then 500th value will be this 5% quantile, right? And then 9,500th value of beta 2 will be what? 95% quantile. And these two values define the 90% credibility intervals. Okay, so to compute 95 credibility interval, you will compute 2.5% quantile and 97.5% quantile, right? Okay. Another advantage from this Bayesian approach is that suppose you would like to inference the difference between beta 2 and beta 3. So this is effect of x2. This is effect of x3 on y, and you wanna compare their impacts on y. Okay, and so then this difference, the measures their difference in the impact on y. Okay, this could be positive or negative or it could be around 0, right? So then you can estimate mean and variance of beta 3 minus beta 2. Okay. Of course, using those samples, you can plot what? You can plot the histogram of beta 1, histogram of beta 2, histogram of beta k, histogram of sigma square, and histogram of beta 3 minus beta 2. Or in general, you can compute any function of the parameters, and then you can plot the histogram. Of course, you can compute posterior mean of this complicated function of the model parameters and variance of it as well, right? So then you can compute any function of the parameters. Okay, so but this 32 minus beta 3 minus beta 2 is quite popular. Okay, and then we can forecast. Then we are going to discuss later. Okay, so then at this point we move to MATLAB programming together. Okay, we are going to do better programming line by line together. Okay.